The next preparation method of phenol is from aniline, the fifth preparation method. Let's check what that reaction is. Very simple reaction. It is aniline. This reaction is also happening in two steps. So step by step I will write. This is aniline, a colorless liquid. Now, firstly, we are going to react it with the mixture of sodium nitrite salt with hydrochloric acid under the temperature of 0 to 5 degrees Celsius, which will give us a highly unstable compound, which I have already discussed with you, that is benzene diazonium chloride. Benzene diazonium chloride. It is benzene. It's a diazo group. If double bond is there, so we will call it diazo, but here the nitrogen is making triple bond with each other and positive charge is there on one nitrogen, highly unstable, obviously 4 bond it is making. So in such condition we will call it diazonium, which is balanced by a Cl negative. Positive is negative, positive is balanced by negative, so benzene diazonium chloride. Highly unstable compound. This compound is stable only up to 0 to 5 degrees Celsius temperature. That's why this we will make under this temperature. After this, we can create phenol very easily because it is highly unstable. This compound directly I am going to write from here. Secondly, what to do? Dilute sulfuric acid or dilute HCl we can use, means we are going to hydrolysis. Dilute means lot of water molecules are available, water, H2O. H2O will break in two parts, H positive, OH negative, and we will heat it. On heating, you can understand from where it will break. Benzene diazonium chloride, please learn. Always they will break from here, nitrogen and carbon, this bond will break because this nitrogen is unstable. So when it will break, obviously nitrogen will get electrons because nitrogen is more electronegative than carbon. So carbon will become positive, positive will be attacked by OH negative, this one. Positive carbon will be attacked by OH negative, so we will get OH here, phenol. Cl negative will be balanced by H positive, HCl. And what will release out from here? Nitrogen gas. This nitrogen already carrying one lone pair. As you know, when nitrogen are making 3 bond, nitrogen is making 3 bonds, 3 covalent bond, one lone pair is there. So this nitrogen is stable, no problem. But this nitrogen was making 4 bonds. Out of 4, one was dative bond, so it is carrying a +1 charge. After bond breakage, it will get its electron back. So both nitrogens will become stable without any charge. This gas, N2 gas, will be released out from here. This is the overall reaction we have. Let's go for its mechanism part. Now, if I talk about mechanism, the first step, its mechanism already I have discussed with you when I have done Ball-Cheeman reaction. In the chapter of haloalkane and haloarenes, please check the making of benzene diazonium chloride from aniline. There I have already explained the role of sodium nitrite and HCl. The whole mechanism is there. Please watch that video. That reaction, aniline to benzene diazonium chloride, have a special name. We call it diassociation reaction. Diassociation reaction. It's a named reaction, diassociation reaction. So from here to here, I'm not going to tell you any mechanism. And From second step, the mechanism is quite easy. Let's write down. When you will heat it, number one, the unstable bond will break. This one, nitrogen was unstable, +1 charge it is carrying. So it will break bond from carbon. Both electrons will shift toward nitrogen because nitrogen is more electronegative. So as it will get one pair of electron, it will become neutral. Because in this pair, one electron is of carbon. So extra electron will make it neutral. +1, -1, neutral. Cl negative will release out because Cl negative was connected with nitrogen due to this +1 charge. But now we don't have +1 charge, so its connection will break. And because this carbon has lost electron, the positive charge will come out it phenyl carbocation. Phenyl carbocation, highly unstable carbocation it is. It cannot be stabilized by resonance. In previous videos I have discussed reason also. Now what will happen? As you know, this is happening in the condition of dilute sulfuric acid. And when I am saying dilute means lot of water, excess water. In excess water, H2O particles are there. This one. And H2O, you know, it will break in two parts, H positive, OH negative. The OH negative will attack on this positively charged carbon. So finally we will get phenol. And this H positive is going to stabilize this Cl negative. Now question in my mind was, why OH negative is attacking on carbon? Why not Cl negative? So the answer is, the amount of water is very high as compared to Cl negative. When I am saying dilute means excess of water. And obviously, these water molecules are going to surround this phenyl carbocation. This phenyl carbocation will be completely surrounded by water molecules because we are talking about dilute condition. Dilute condition means a lot of water. A Cl negative is not in the proximity of this phenyl carbocation. Water molecules are there. So water molecules have more chance to attack on this phenyl carbocation, and they are getting that benefit of the close proximity with phenyl carbocation. So they are taking the advantage of that. OH negative particles are going to join directly on phenyl carbocation and phenol will generate. And this reaction you can understand in this fashion also. Sometime we understood this reaction in this fashion also. The phenyl carbocation will be attacked by water molecule. Sometime we understand this reaction in this fashion also. Look, this whole water molecule will attack on it. Obviously on this carbon, vacant orbital is there. Oxygen is carrying lone pair. So directly it will attack like this. And after attack, between carbon and oxygen, dative bond will generate. One electron, it will completely transfer toward carbon. So this oxygen, only one lone pair will left. Because it has shifted one electron completely toward carbon, so what charge will develop? +1. As you know, oxygen in +1 is unstable. What it will do? It will break bond from hydrogen. And when it will break bond from hydrogen, both electrons, it will shift toward itself and hydrogen will release out as H positive with a vacant orbital. Because one electron was gone toward oxygen side and oxygen will become neutral with two pair. One extra pair will generate over here. One electron will be of hydrogen which it got and this +1 charge of oxygen will finish. So OH negative, OH will join out this benzene, phenol will generate. H positive will stabilize Cl negative. In this fashion also we can understand that reaction. Both ways are correct. You please don't worry how to write this mechanism. This mechanism, this direct H2 attack you can write or directly OH negative you can attack on phenyl carbocation. Both are right. That's it. This is the end of the videos. fifth preparation method. Only sixth preparation, last preparation method is left. We will check in next video. Thank you very much.